So the two big ideas in section 0.2 are the idea of finding intercepts and determining the symmetry. And those things will come up again and again. So they're pretty important things to get down so you can have them down at the next level. When that next level comes up, you'll want that, okay? So let's look at somewhat the easy thing is, where is the x-intercept on this graph? Where is the x-intercept on this graph? -3, because that is where the graph crosses the x-axis. Now, one somewhat curious thing that the program will require you to do is not report it as -3, but report it by its full coordinates, x equals -3, y equals 0, or -3, 0. That's one thing. The other point that's going to be useful when we get something like this, instead of having the graph, we have the equation, is to remember that if x equals 0, or if it crosses the x-axis, the x-intercept, then we've got y equals 0. If it's where it crosses the x-axis, it's the x-intercept, then y is equal to 0 at that point. Similarly, what are the y-intercepts? 2 and -2, and again, so the book wants it 0, 2, and 0, -2. And again, our y-intercepts are places where it crosses the y-axis. It's places where x equals 0. Now that's going to be useful if, instead of seeing it as a graph and having the intercepts be obvious, if we've got the equation of the relation written out. Okay? So we've got x equal y squared minus 3. Where are the y-intercepts? Well, the y-intercept, or intercepts, is where x equals 0. So I simply substitute 0 in for x. And solve the equation. Not as nice of an equation as I hope, but we'll be able to handle it. Okay? So, y squared minus 3 equals 0. It's tempting to just say, okay, let's add 3 to both sides. Good play. And it's tempting when you have one of these y squareds to say, gosh, if y squared is equal to 3, y equals the square root of 3. Because the square root of 3 times itself equals 3. But remember, with a square, we're going to be dealing usually with two solutions, because of the fact that not only does the square root of 3 times itself equal y, but the opposite of the square root of 3 will also work. Both of these things are our x-intercepts. So our x-intercepts, or excuse me, our y-intercepts are at 0, square root of 3, and 0, negative square root of 3. For our y-intercepts, excuse me, that was the y-intercept, sorry. For our x-intercept, there happens to be only one. That occurs where y equals 0. And so we've got x equals 0 squared minus 3, or x equals -3 is our x-intercept. And so, well, that's terrific, except for that is not this thing here. Okay, so just be aware that is how to find the intercepts of this thing. X equals 3, x equals -3, so the point -3, 0. But I messed up in terms of this is not the equation of this guy right here. Okay? So finding intercepts when you don't have the graph is just a matter of substituting 0 in for x and 0 in for y. Okay? Finally, there's this issue of symmetry that comes up in 0.2. And what you got to do is picture, best thing here, take a sheet of paper from up here. Here we go. Picture folding a sheet of paper here. If you have symmetry with respect to the y-axis, that means if you fold the graph along the y-axis, one half of the graph will end up on top of the other. So for example, this parabola here, if I've drawn it correctly, if you fold it along the y-axis, these things, these points here will end up on top of these and vice versa. That's symmetry with respect to the y-axis. Symmetry with respect to the x-axis is sort of like that parabola over there. If you fold the piece of paper along the x-axis, one set of points will end up on top of the other. Each point here has an image on the opposite side of the x-axis. Symmetry with respect to the origin takes a little bit of getting used to. Okay? So here's a graph that's symmetric with respect to the origin. And the best way to get it is to go back into the coordinate plane. Let's say this is the point -3, or +2. X equals -3, y equals +2. If the point -3, +2 is on the graph, then so must the point 3, -2. So every point on this graph has an image that has the opposite x coordinate and the opposite y coordinate. And that's going to be symmetry with respect to the origin. Okay? With that in mind, that quick refresher in mind, that is where you want to be going in section 0.2.